Hi, welcome to another video on my Raspberry Pi 2 running Ubuntu Linux and the robot operating system. Last time I managed to get a circuit running with an LED. When I click this switch, this LED is going to work. Now I can go one step further and introduce a light dependent transistor. This one, also of fischertechnik. And when light falls on it, the state goes high, and the other way around, of course. Now the idea is to keep this transistor somewhere like this, responding to this LED, if possible, and then see how this responds. And how does this correspond to the robot operating system? Well, if I manage to get this working, I can also create a node that says, alright, I receive a plus, so I can light up another LED. So that is the idea behind the new experiment. The only thing is, how do I connect it? First of all, also I need to remove these parts, jump wire and LED, because in the current situation they make no sense of using. So with these two cleaned up, it is time to figure out how things will work, and I prepared this wire with part of staples that nicely fit in here, but I need it to be connected to the ground. So I take just a resistor, and this time I think it is 180 ohms, which is lower than this one we have for 330. But right now I don't mind really, so I put it in, and this one should be connected to the power. And there comes some thinking, because when using fischertechnik I can just put it to a digital input, which is powered or not. And when I look here, there are some connectors left, and when I look at the connectors that I have already used, I see here 11, and then I have possible 13. So I think I am going to wire it up to 13. So this one is going in just any other lane. Pick a wire, it's pretty long, but that is okay. Put it in here, and the other end of the wire is going into pin 13, if I am calculating it correctly. So, and let me by any means show the camera. So this is 1, 2, 3, 4, no, 1, 3, 5, 7, 9, 11, 13. And I have to make this wire correct. So it is going into this one if it wants to. And also if it doesn't want to. Alright, so this is connected. Yet it doesn't do anything because it's not programmed. So let's take care of that first. So what I am first going to do is adjust the subscriber code to be able to read from 13. So what I have to do here, GPIO.setup 13, comma GPIO in. Then I can say, alright, if so, these are listeners. I should put the data in here somewhere. These are all callbacks, and they are responding to the lights. In this case, it lights up an LED or not. And I can also say just an if GPIO that's a good one. Let's take it from here. If GPIO input 13 is 1, oops. Then, well, screen output. So I say print light sensor. Let's call it that way. Is high. And that, well, I can use that, of course, using the lamp that is shining on the breadboard. So let's save this and test anything. I will start the notice now. This is started. This is started. Oh. Yeah, this is wrong. This should be quote. Now things are going. So right now I don't see anything happen. So let me interrupt this and adjust the code to else if GPIO dot input 13 is 0, print light sensor is low. And actually this should be independent of how the switch is being held. So yes, this is low. Now I am going to say so you see on the camera that the light that the LED is lighting up when I press the switch. But how is the output to the light sensor? It is still very low. Which may raise the question, if I take another light like this small flashlight, is that changing anything? Right now I am shining straight on it and light sensor stays low. So this raises the question, okay, what is it anyway? That's a very good question. And this may mean that I have to check the sensor. So let me do that. The diagnosis has shown that this light sensitive transistor is actually working great. Which raises the question, why is this light sensor still low? The answer may be in the voltage that is given, because last time it showed that the voltage has to be over 1.5 volt to be regarded as being high by the Raspberry. So that is exactly what I'm going to do. I will just start the software, which is not strictly needed right now, but on the other hand, if I want to see any changes here, then I better run it. So that's one thing. Next, I have here hooked up the ground probe. Here I have the power probe, and I have a multimeter. So right now I'm measuring absolutely nothing. Holding it to the light reveals that it is absolutely nothing. So what should I do? Actually shine light on it, because during the verification with the diagnostic software, shining light on it was just all it needed. And right now it does nothing at all. There's no voltage running through it. So the question is, am I doing this right? Should it be helpful to actually put the whole thing different, that I will have to say, alright, now it is an input, should I make it an output? But making it an output, is that logical? Maybe yes it is, because it is a light dependent transistor. Making it output always has current through it, and by shining light you make it go on and off. So actually I think that is the best idea. Make this, instead of an input, an output. Then saying also it must be high, and then this condition is different, very different. So apart from this, I am going to say, alright, GPIO dot output 13, true. So when I run this, the output is going to be true at any time. And then the question is, what will it be? So this is going to be of no meaning anymore. But then I need something else to report if something is low or not. So how should I do that? I need another pin to read if it is going correct or not. And that's a good point. So I need an LED, for instance this one, to be connected to yet another pin on the Raspberry GPIO to show yes or no voltage block or not. So yeah, that is what I'm going to do. Alright, I did set up an external LED, this one, but my reasoning is not entirely correct, because this light dependent or light sensitive transistor is both input and output. This is input to the transistor, output from the RPIO, and this is exactly the other way around. That means that I should not connect the green to the ground, but to one of the pins. And that is easily solvable when I remove this resistor, take this wire that I already had connected to 13, no, to 15, and I connect it to the ground. Or the green wire anyway. So then I have to reconnect this carefully to pin 15. Hope that everything stays in place. So these are no longer connected. So now I should change this code and add a GPIO setup 15 to GPIO in. And now I can say, alright, this is going to be 15. And then I should be able to get some results. So now, provided that the voltage is correct, let's see what happens. It's still experimenting, but I think this should be it. Enter. Light sensor is high. Now what happens if I shine light on it? Okay, let me see what I do. I shine light directly on it. It says high. So GPIO input is 15. Input 15 is high. But when I remove it and I put my thumb on it, it should be low. And that is not happening. So somewhere my reasoning isn't entirely correct, apparently. And yet, when doing the diagnosis on this sensor, it was completely accurate. It responded just the way it should. Holding my thumb over the sensor, and it remains high. So that is not what I want. Where do I go wrong? Yeah, this needs some thought. Once again, it reads it, and here I have said this is always true. 13 is always true, which is in a matter of fact correct, because, as a matter of fact, because it drives the sensor. And this wire indeed goes to 13. So why is it always high? Should I put a resistor in between? That may be so. So let me just do just that. I put a resistor in between the green and the feed to 15, but it still stays high. Let me run it again. Light sensor high. It's low. It should. Yes. Yes. Oh yes. I saw low. But only for a moment, I'm afraid. I end it. Start it again. Yes, it gets low, but apparently not that I can really control it. So the question is, why is that? I saw low flashing by, but as long as I have my finger put on it, literally, it should say low, and it doesn't do that. Okay, once again, some thinking to do. Alright, I have decided to change, put the camera a bit higher, to change this resistor for the same value as this one. So out goes this one, and in, I don't know if it will matter, but we'll see soon enough. Alright, I am once again covering up. Releasing, covering up. Now each cover up should be a low. And certainly when I point it straight to the light. So why is this not happening the way I expect and want? Did I see a low passing by? Yes, now it is low. And stays low. Oh, that's a rather interesting conclusion. Or change of effects. So why is it low now suddenly? Shining with the light on it. It stays low. Oh, that's an interesting change in events. Covering up. This should be low, but this should be high. Okay, let me so what is causing this sudden change in behavior? I don't really get this. The wiring seems to be okay. Alright. It doesn't work entirely as I expect. That may be clear. The idea is nice though. And this is the end of this episode. In which I didn't do anything else but trying to add this light resistant transistor, light sensitive transistor, which can make you say, okay, this is high and this is low, and it influences something like output or an LED. I'm going with it next time. Going on with it next time. Thank you for watching. If you like this video and you haven't subscribed yet, please consider subscribing, or please do subscribe to my channel. Lots of other topics as well. If you don't want to subscribe for any reason, I'm also on Twitter and Instagram. Twitter has active links, and Instagram you have to paste and copy and paste the link. Also, if you like it, please consider to make a small donation to my PayPal, of which you can find the link and more information on my website. And my website has lots of other information as well. This is going to be continued. Bye bye.